Hi, I'm Ximena, and I'm going to talk about our work, A Look to Languages Through the Glass of BPE Compression. Linguistic typology studies the different languages of the world and tries to establish the relationship among them. In particular, at the morphological level, we would like to group languages according to their morphological structures and to study some relationships, for example, trade-offs or the relationship between morphological irregularity and frequency, just to mention a few. This usually requires deep linguistic knowledge and access to linguistic annotated data, which is not always available for all languages. So we wonder if using text corpus that it's available for many languages, if this could provide a good alternative to test or to quantify typological hypotheses. So in order to do that, in this work, our starting point is the well-known BPE, which is widely used in NLP for performing subword tokenization. The obtained subwords through iterative merge operations capture morphological irregularities to some extent. We can see this as a compression in a way that at each operation, BPE is merging the most frequent adjacent subwords, and by this, we are reducing spaces or the code length. In a previous work, we noticed that regardless of the language, the first BPE merge operations tend to have the stronger impact on the compression of the text. So this means that the first merge operations capture subwords that are highly recurrent, and this caused the most drastic changes in the text. After a certain number of merges is reached, the changes in the compression are not so drastic anymore. However, the natural language properties that allow this compression are rarely analyzed. So one might wonder if all languages get compressed in the same way through BPE merge operations. Our hypothesis is that the type of recurrent patterns captured at each merge depends on the typology, at least partially. For instance, for some languages, this compression achieved on the first merges might be related to frequent affixes or regular inflectional phenomena, while for some others, it might be related to more idiosyncratic or irregular patterns. Furthermore, this can be interpreted in the light of typological implications that we will explain later. So inspired by the notion of morphological productivity in linguistics, we proposed a way to classify the type of patterns captured by BPE. So for each merge operation, we quantify whether the newly created subword has a tendency to be more productive or more idiosyncratic. We focused on the first 200 merges, and we work with 47 diverse languages. We use the parallel Bible corpus. So for instance, see this example. We notice that some subwords like ed at the end of the word appear in many different word types. Thus, they seem more productive. Note that also the cumulative frequency or the total frequency is high. While some other subwords like had are only contained in one word type of the corpus. Actually, they are contained in the word itself. But the frequency of that single word type is very high. So we came up with a measure to reflect that, and we call it idiosyncrasy. So ideally, low values of idiosyncrasy reflects a productive pattern, which would mean that this subword can be applied to many different lexemes, while higher values of idiosyncrasy reflects a non-productive pattern. So this subword won't appear in many different lexemes, but it can be very frequent. This is our operationalization. And here we are simply checking how many word types contain that subword and what is the frequency of those word types. We can think of this as 3 dimensions that are characterizing each subword. And the idiosyncrasy is a function of the types that contain the subwords and the cumulative frequency. So subwords that have low values of idiosyncrasy, it's probably because many word types contain that subword, and additionally, the cumulative frequency of those word types is relatively high. So here in this area, we would expect to see highly productive patterns. On the other hand, When we have high values of idiosyncrasy, it's probably because few word types contain the subword, and also the cumulative frequency is relatively high. So here we would expect to see patterns that are not productive, but they are quite frequent. This is how it looks if we plot the first 200 BPE subwords for different languages. The color indicates the number of merge operations in which the subword was created. So lighter colors indicate that the subword was created on the early merge operations. We chose these representative languages just for the sake of illustration. And we can notice that the exact way in which subwords distribute across the space and also which ones get merged first depends on the language. So for languages with rich inflectional morphology like Finnish or Kalaallisut, there are many subwords with low levels of idiosyncrasy and highly productive. We think that subwords that correspond to regular morphological patterns might be around this area. Also, these subwords that are captured, these subwords that are regular, seems that they are captured during the first merges for these languages, so they are good candidates for compression. And for languages with less inflectional morphology, there is a more prominent concentration in the area where the idiosyncrasy is high. Here also, these types of subwords not only are high in idiosyncrasy, but they are also a good candidates for compression for this type of languages. So they get merged first. So we think that in this area, we are seeing subwords that correspond to morphological phenomena that it's not very productive, but it's quite frequent, like irregular or subjective phenomena. And also here we see whole words that get merged relatively quickly since their frequency on the corpus is high. The more merge operations, the more the languages tend to behave similarly. So the subwords start to accumulate closer to the origin since they appear in fewer word types, and those word types are not very frequent. This explained why the subwords formed at later merges have a smaller effect on the change on the compression. We can also think in terms of trade-offs. We have found that the average idiosyncrasy of the subwords is negatively correlated with the word unigram entropy. So languages with rich inflectional morphology, in these cases, the subwords tend to be more productive, while for languages that do not mark all this grammatical information at word internal level, the subwords tend to be more idiosyncratic. This seems consistent with the ongoing discussion related to morphological complexity in natural languages and information theory. Related to this, we know that in linguistics, the relationship between morphological irregularity and frequency has been widely studied. And some studies argue that morphological irregular verbs are memorized and stored as whole items, while regular verbs are generated using patterns that are predictable. So our approach could be a way to quantify this across many languages without the need of annotated data. Finally, we can't compare languages with respect to each other. For instance, which ones tend to have more idiosyncratic or regular constructions based on BPE merges. We circle the languages that we showed before, and we can see that English and Sango tend to have in average more idiosyncratic subwords than languages like Kalaallisut or Finnish. This is still an ongoing work, but so far we have found that for languages that are morphologically rich and with regular inflectional morphology, BPE shows a tendency to merge subwords that are productive according to our measure. And also for languages with poorer morphology or with less regular patterns, BPE will tend to merge subwords that are less productive but with a high level of idiosyncrasy. Finally, we think that corpus-based or text-based approaches are an relatively easy and reproducible way to look at typological phenomena in our field. Thank you.